Hello, Coach Travis here with another calculus video. So this is a problem about exponential functions, a question regarding the graphs of exponential functions. So basically the idea is here, what we want to have is we want to have an idea of what the graph of 1/8 to the x power, what does the graph of that function look like? So what we need to do is we need to remember that, okay, so an exponential function is one that has the form f of x. Actually, I should write it off to the side here, sorry. F of x is equal to a times b raised to the x power, where b has to be non-negative and b cannot be equal to 1. And so the things that you want to remember is that if b is greater than 1 and a is positive, so if nothing's negative, so if a is positive and b is greater than 1, then the graph is going to roughly look like this. And if a is positive but b is less than 1, then the graph is going to look like this. So essentially what we have here, the way I think about it, is that if b is greater than 1, then it's exponential growth. So like 1 is like 100%. So if b is bigger than 100%, then the function's going to be growing. Whereas if b is less than 100%, that means that the function is going down. So all right, so that, I think we can answer this question here then, because in this problem we see that, well, b is 1/8. So in this particular problem, we've got that, where should I write it? B is equal to 1/8. And 1/8 is obviously less than 1. So this is, excuse me, so this is definitely going to be an example of exponential decay. So we know that we're going to have something that looks like this. So all right, so that rules out, this first one is obviously not correct. Okay, the second one looks pretty good. So we'll hold that, we'll think about that one. The third one is obviously not correct because that's exponential growth. And then the last one is also an exponential decay. Okay, so now what you say is, okay, great, Travis. Which one is it? Is it the second one? Or is it the third one? Sorry, the fourth one. Oh, there's a fifth one. Oh my gosh, there's a fifth. I don't know. There's a whole bunch here. I can't keep track. So all right. So okay. So we see that, okay, we don't have any obvious candidates. So okay. So at that point, then what you do is you start plugging in numbers. So that's always something that can work. So let's get rid of this. And let's just, let's just plug in a few numbers, just some real simple ones, and hopefully that'll be enough to get us through the problem. So I'm going to have x, and then I'm going to have 1/8 to the x. And so, okay, so let's take x to be 0. Okay, if x is 0, then we have 1/8 to the 0. And 1/8 to the 0 is 1. And then let's try 1. So if we put 1 in for x, then we get 1/8 to the 1, which is pretty easy to see as 1/8. And why don't we go ahead and try negative 1? And if you think about that, well, let's see, that's going to be 1/8 to the negative 1. But remember that when you do have a negative exponent, that is actually a reciprocal. So that's going to give me 8. So okay, so that was actually pretty easy. That didn't take very long. And now I think we can uniquely identify our answer at this point. Okay, so we know that it's not this first one. Okay, and now let's look at this next one. It looks like, okay, when x is 0, then y is 1. So that looks good, because when x is 0, y should be 1. When x is 1, y is really close to 0, and 1/8 is pretty close to 0, so that looks good. And when x is negative 1, it looks like y is 8. So I have a really good feeling about this one. I'm pretty sure that this is the right answer. But just to be sure, let's check the other candidates. So anything that roughly looks like this, we know is a candidate. So let's scroll down and see the ones that look like that. Okay, so this one's a candidate. Okay, it's got the correct y-intercept, but look at what happens when you put negative 1 in. When you put negative 1 in, you only get about 3 out. So this one can't be it. And then if we scroll down some more, yeah, when you put negative 1 into this one, you only get positive 1. So I should comment. So this was a key fact right here. This was really useful to us. And then this last one, if we put in negative 1, it looks like the function's way bigger. Oh, actually, there's an easier one here. Well, if you put in negative 1, you get something that's way bigger than 8. And also, it doesn't even have the correct y-intercept, because we said the y-intercept should be at 1, whereas this one's at 2. So, all right. So we confirmed that this one definitely is the graph. So to summarize, how did we do that problem? We said, first of all, we looked at the function and we decided, we figured out, is it going to be exponential growth or is it going to be exponential decay? And if the base is less than 1, then it's going to be exponential decay. So we knew it had to look like this. And then once we knew that, then we fine-tuned things by just plugging in a few points, because then that allowed us to differentiate between all of the decay graphs that we saw.